What's up guys, this is Massey. Welcome to another video. In this video I want to talk about Cartesian vectors. Suppose we have a vector, we call it u, and this u is any vector in a plane with endpoints q and r. We identify vector qr as a Cartesian vector because its endpoints can be defined using Cartesian coordinates. For example, if we translate this vector u so that its tail is at the origin, which is 0 and 0, point O, then its head will be at point B, and the components are a and b. Then we define these special Cartesian vectors as a position vector. The x is a, the y is b, and we put it in square bracket. We use square brackets to distinguish between the point and the related position vector. So whenever we have round brackets, we call it a point. Whenever we have square brackets, it means that we are dealing with a position vector. So a and b is also used to represent any vector with the same magnitude and direction as OP. So it doesn't matter the location, direction and magnitude is only important. Now let's see what does that mean when we are talking about unit vector. So in 2D, we call unit vectors as vector I and vector j. So unit vectors are I and j. The magnitude is 1, but the direction is different. Vector I has the magnitude of 1 and the direction is in x direction. Vector g, the magnitude is 1 and it is in y direction. So I and j are the building blocks for Cartesian vectors. Unit vectors have magnitude 1 unit. I and j are special unit vectors that have their tails at origin, and the head of vector is on the x-axis, which is 1 and 0, and the head of the vector j is on y-axis, which is 0 and 1. In the notation for Cartesian coordinates, I is 1 and 0, and j is 0 and 1. Later on, we will see in 3D or 3 dimensions, we have I, j, and k. Vector k is going to be on z direction. And in that case, unit vectors I, j, k, I means 1, 0, 0, j means 0, 1, 0, and k means 0, 0, 1. So now let's see how can we find out the magnitude of the vector. Any Cartesian vector, v, containing v1 and v2 can be translated so its head is at the origin 0 and 0 and its tail is at the point v1 and v2. To find the magnitude of the vector, we use the following formula. V vector equals to square root of v1 squared plus v2 squared. Now let's see how to add vectors. To add two Cartesian vectors, u containing u1 and u2, and vector v containing v1 and v2, use the unit vectors I and j. So we can say u plus v is going to be u1 u2 plus v1 v2, and when you add them, it's going to be u1i plus u2j plus v1i plus v2j. And when you collect the like terms, at the end you have u1 plus v1 as the x component, and u2 plus v2 is going to be at y component. Now let's see how to multiply a vector by a scalar. So when we have k multiplied by vector u, it's going to be k times u1, u2. So the x component is going to be ku1 and y component is going to be ku2. Let's see an example. Given the vectors a, 5 and negative 7, vector b, 2 and 3, determine each of the following. So part A says, and find an expression for a in terms of its horizontal and vertical vector components. So the vector a is 5 and negative 7, so it means that we have 5, magnitude is 5 in x direction, and magnitude is negative 7 in y direction. So it's going to be a equals to 5, 0 plus 0, negative 7. Part B, it says, find an expression for b in terms of I and j. b is 2 and 3, so it's going to be 2i plus 3j. C, we have 3 times a. So we're going to have 3, which is a scalar, times vector 5 and negative 7. So when you multiply it, it's going to be 15 and negative 21. Part D is going to be A plus B, which will be 5 and negative 7, 2 and 3. So we need to add the x component. So 5 plus 2 is going to be 7. And then negative 7 plus 3, which is going to be negative 4. So the final answer is going to be 7 and negative 4. Part E says 2a minus 4b. How to do that? Again, we have 2 times 5 and negative 7 minus 4 times 2 and 3. So the x part is going to be 2 times 5, which is 10. And the first one is going to be 2 times negative 4, negative 7, which is going to be negative 14, minus 4 times 2, 8, and 4 times 3, 12. Then we can have 10 minus 8 for the x component, negative 14 minus 12 for the y component. So final answer will be 2 and negative 26. Part F, it says 2 unit vectors collinear with vector A. So 2 unit vectors collinear with vector A. And we have 5 and 7. So a vector collinear with A is going to be k times A. Find a value for k so that ka has magnitude 1. So we can say k times A, or magnitude of k times vector A, has to be equal to 1. So 5k and negative 7k has to give us the magnitude of 1. So 5k squared plus negative 7k squared, which will be 49 plus 25, that will be 74k squared equals to 1. So k squared is going to be 1 over 74. So k will be plus minus 1 over square root of 74. So we have 2 vectors. Part X, first part is going to be 5 over square root of 74, and y is going to be negative 7 over square root of 74. Or you can say negative 5 over square root of 74 and 7 over square root of 74. If you check the magnitude, which is going to be x squared plus y squared, square root of x squared plus y squared, that has to give you 1. Now let's see the last part, which is saying that the magnitude of A minus B. A is 5 and negative 7, B is 2 and 3. So we can say 5 minus 2 and negative 7 minus 3. So we have 3 and negative 10. So when you want to find out the magnitude, it's going to be 3 squared plus negative 10 squared. And the answer will be square root of 109. Now I want to talk about Cartesian vector between 2 points. Let's P1, x1 and y1, and P2, x2 and y2 be 2 points on the coordinate plane. Then vector P1, P2 equals to vector P1O plus OP2. And we can say P1O is negative OP1. So the answer is going to be vector OP2 minus vector OP1. OP2 is x2, y2 minus OP1, which is x1, y1. So we end up having x2 minus x1 and y2 minus y1. What is going to be the magnitude of P1, P2? That would be square root of x2 minus x1 squared plus y2 minus y1 squared. Now let's see the second example. Find the coordinates and the magnitude of Cartesian vectors between 2 points. Find the coordinates and the magnitude of each vector. Part A. Vector AB for A is 1 and 3 and B is 7 and 2. So A is 1 and 3, B is 7 and 2. So AB is going to be 7 minus 1 for the x, and 2 minus 3 is going to be for the y. So it's going to be 7 minus 1 is 6, and 2 minus 3 is negative 1. What is going to be the magnitude? It's going to be square root of 6 squared plus negative 1 squared. That will be 36 plus 1. That's going to be square root of 37. Now, part B, we have vector CD. C is negative 10 and 0, and D is 0 and 10. So that will be vector x2 minus x1 y2 minus y1. So that will be 0 minus negative 10 and 10 minus 0. So we have 10 and 10, and the magnitude is going to be 10 squared plus 10 squared. So we have square root of 200. Part C, we have EF. E is 4 and negative 3, and F is 1 and negative 7. EF is going to be 1 minus 4 and negative 7 minus negative 3. So 1 minus 4 is negative 3. Negative 7 minus negative 3 is going to be negative 4. So the magnitude of EF will be negative 3 squared plus negative 4 squared. So that will be 9 plus 16. That will be 25. And the square root of 25 is 5. Next example. Write a force of 200 Newton at 20 degrees to a horizontal in Cartesian form. So that's going to be simple. We have magnitude of force times cosine theta and magnitude of force times sine theta. So it's going to be 200 cosine 20 and 200 sine 20. 200 cosine 20 is 187.9, and 200 times sine 20 is going to be 68.4 Newton. So these are going to be the Cartesian form. 187.9 in x direction, 68.4 in y direction. Next example, velocity and bearings. A ship's course is set to travel at 23 kilometers per hour relative to the water on a heading of 40 degrees. A current of 8 kilometers per hour is flowing from the bearing of 160 degrees. Part A, write each vector as the Cartesian vector. Part B, determine the resultant velocity of the ship. So we can say that headings and bearings are measured clockwise from the north, which is equivalent to clockwise from the positive y-axis. So these have to be converted to angle with respect to the positive x-axis. So the ship is traveling on the heading of 40, which is going to be 40 degrees from the positive y-axis, as you see here in this picture. So this is equivalent to an angle of 50 degrees from the positive x-axis. Let S represents velocity of ship. That will be 23 times cosine 50 for the x-axis, and 23 sine 50 is going to be y-axis. The velocity of ship can be expressed as these two numbers. The current is flowing from a bearing of 160, which is going to be equivalent to 110 with the positive x-axis. So the current is flowing at 8 kilometers per hour. So we can define vector C as 8 times cosine 110, and y component is going to be 8 times sine 110 degrees. So let's say R represents the resultant velocity, which is S plus C. S is 23 cosine 50, 23 sine 50, plus 8 cosine 110, 8 sine 110. So when we simplify it, the vector R is going to be 12.048 for the x component and 25.137 for the y component. And we can easily find out the magnitude of R, which is going to be square root of 12.048 to the power of 2 plus 25.137 to the power of 2. That gives us the magnitude of 27.875. So the bearing angle, we can say beta equals to inverse of tan 12.048. That's the opposite divided by adjacent, which is 25.137. So beta is going to be 25.6 degrees, and the ship is traveling at a velocity of approximately 27.9 kilometers per hour at the bearing of 25.6 degrees. Now let's wrap up and the key concepts. Unit vectors I is 1 and 0, and J is 0 and 1, has magnitude 1 unit and tails at the origin and points in the direction of positive x and y axis respectively. A Cartesian vector is a representation of a vector on a Cartesian plane. Its endpoints are defined using Cartesian coordinates. If a Cartesian vector u is translated so that its tail is at the origin 0 and 0 and its tip is at the point u1, u2, the translated vector is called the position vector of u. The position vector and any other vector with the same magnitude and direction is represented by the ordered pair of u1, u2. The magnitude of u is going to be square root of u1 squared plus u2 squared. Any Cartesian vector u1, u2 can be written in the sum of the vertical and horizontal vector components as u1, 0 and 0, u2. For vectors u containing u1 and u2 and vector v containing v1 and v2 and a scalar k, we can say vector u plus vector v equals to u1 plus v1, u2 plus v2. U minus v will be u1 minus v1, u2 minus v2. And k times v is going to be k v1, k v2. The Cartesian vector between 2 points, p1 as x1, y1 and p2 as x2, y2 is p1, p2, and the x component is going to be x2 minus x1 and y component is going to be y2 minus y1. Its magnitude is going to be x2 minus x1 squared plus y2 minus y1 squared. And then we need to find out the square root of it. Geometric vector v can be written in terms of Cartesian form, which is going to be v, the magnitude of v times cosine theta and magnitude of v times sine theta, where theta is the angle v makes with the positive x-axis.